So this one's just a quick video on a device I was thinking about. Cool, it must have been about 18 months ago, give or take. And it's a device that generates power to run itself. It's a self-operating power. And it's got to have enough power left over to supply humans that were on Mars or on the moon or in space. So it's got to be able to constantly generate power that runs itself. So it's able to run the device itself, generating this power. And it's got to then have enough left over that we can take to use for heating, cooling, cooking, whatever you want to use it for, keeping your life support systems running. So this device, I sat down and thought about it. How could we do this? It's got to be affordable. Now, I used an MRI machine, and it's only because people understand the concept of an MRI. So, electromagnetic field, if you understand that. If you've ever been around an MRI machine, they'll tell you don't take anything that's metal, because it will just be pinned to the machine. It's got such a strong magnetic field that anything metal, oxygen tanks have to be, if you go into an MRI machine, you can't take a metal oxygen tank in there because it will just fly out and fly into the machine. So on my website, there was this thing, I think it's called under the tab of power, mycontentions.com, and it's under power. If you look it up, there is also a link on there that someone on YouTube made a video showing just how powerful an MRI machine is when it versus metal. And they used this chair, they used a chair, really strange, and a device that measures how much pull something is exerting on the chair. And this chair was fastened to a wall behind them using lots of different mechanisms just to hold it in place. And they turned the MRI machine on and it started to pull the chair in towards it because it was metal. And yeah, basically the meter that they were using overread. It basically, if it had carried on going, I think the whole thing would have broke, and I think it did break in the video. Just to show you how much pull on metal objects an MRI machine has is just overwhelming. So check that out because that link is in the video. And what do you call it? It's absolutely crazy. It's extraordinary. So I love MRI machines because of this power that they've got. And the second one is motors. Nikola Tesla, invention of the motor. It's absolutely brilliant. So without motors, you know, your car wouldn't operate properly. We wouldn't be having electric vehicles right now. Alternators wouldn't work. Fans, air conditionings, you name it. Most things rely on a motor. Wash machines, tumble dryers, you name it. So great invention, really good invention. And the next invention that is I really like is Clockwork. All of those mechanisms in Clockwork. Now, again, another great invention. Without it, where would you be? Well, we'd have to look at the sky. Well, it feels about like it's 4 or 5 o'clock. But clock, you know it. So again, and quartz as well. So that helps. Now, all of these inventions on their own are superb enough. Now, what I did with these was incorporate all of them into making a power device, and it doesn't give you free energy. It's not how... I don't like the word when people say, oh, it's free energy devices, oh, it's free energy. Nothing is free. Let's just get this right out of the way with first. So, nothing is free, because you've got to pay somebody to make the clockwork. You've got to pay somebody to make the motor. Someone has to make that, and you'll be like, oh, well, it was done by a machine, but someone had to build that machine. So nothing is free, and someone has to go into a lot of detail to get this up and running and operational. So no, it's not free power. And then there's wear and tear costs. So, you know, a motor, where it's great, it eventually will burn out, so it needs to be replaced. That's maintenance. Again, that's not free. And then there are different pulleys and different all sorts. You know as well as I do, if you've got a car and you've got the engine running, After a while of just running that engine, bearings are going to get worn, motors are going to wear out, things are just going to break eventually. That's just what happens. It's wear and tear, it's byproduct, energy transforming into other energies and heat and different things. And things go a bit pear-shaped when we have this constant force upon them of operating. So free energy devices? No, it's not. So yeah, anyway, so back to the power idea that I've been playing around with it, to be honest. So MRI machines for their extreme power on their pull. Now, I've drew this as best as I can. Now, there is a version 2 coming for this. So this is just the stage just to get the principle. I'd love to build this, to be honest. To have the money to build this would be absolutely fantastic. Now, another reason why I use the MRI machine, talking of space, I love space travel. The day that humans can have a holiday on the moon. Okay, we're a bit extreme, but still, the day that humans can have a holiday on Mars. I mean, wow, would you? Yeah, most people love to travel to different continents on this planet. You throw an idea of how about going and spending a weekend honeymoon on the moon? Literal honeymoon, literally. I mean, you just get to eat honey all of the time and you're on the moon, so that is your honeymoon. Okay, back to the drawing board. Anyway, but still, if you were to put this in the way of humans, we would love to go. Why? Because, oh, that's fascinating. It's Christmas time. Get your ice skates, kids. Why? Where are we going? Well, we're going to ice skate on Europa. Okay, that one's a bit extreme, but still, could you imagine that? This would get humans going and we could go out into space. Well, before we get into all of these crazy ideas, honeymoon and ice skating on Europa, yeah, surfing the rings of Saturn. Okay, that sounds really wrong. But anyway, yeah, still, I'm not gonna edit that out. That's funny, but in a way. So, imagine doing all of these things, but in order for you to do that, you're going to need energy and a good enough system that is reliable enough that it's not going to burn out or taking oxygen or pose a risk. So, you know, nuclear power is very expensive. I just don't see... It's risky. I call it risky. It's fantastic, yes, okay, fair enough. But it's so risky. What if? I mean, I was sitting there thinking to myself... I like to try and find problems before they arise with any inventions that I do, and I suggest that anybody else that is inventing stuff do the same. Find your own problems before they happen. Play the what if game. I love it. So you've built something, you've got it, and you think, yeah, this is pretty good. I like this idea. This is going somewhere. Now destroy it in every single way you can imagine. Destroy it. Why? Because this will let you build contingency plans. There you go. Look at that. Trying to get these words out. Like eating them today. Got an appetite for words. There's another one. Anyway, so it helps you build the stages of the what if scenario. It goes wrong. What can you do to lessen the blow? Okay? Now I do this with a lot of things that I invent. So I sit there, build something, and I'm like, right, okay, now I'm going to destroy it. Okay, so this could go like this, and this could go wrong, and that could go wrong. Okay, so what could you do? Well, if you change this every so many months, that won't happen. Eliminate this, blah, blah, blah. So you have this idea that started as pretty good, and now you've got a whole load of problems because, you know, at the end of the day, you are your worst critic. And being your worst critic means that, well, you'll find things that others will try and look for in your stuff, but you should know your own failures within your ideas or your inventions in order to say, yeah, but if you did this, 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 and had some maintenance work done, blah, 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 X, Y, Z, this would not happen. So it then throws in an obstacle that you can overcome very easily. So with this one, I knew that there were going to be some obstacles that needed to be overcome. So I played the what if game with it, so try and destroy it. So this could happen, that could happen, you're going to need to change the motors, you're going to need to do this, the bearings are going to wear out. But if you are able to get some decent bearings and some decent motors, and you combine them, but you change them every so many months, but hey, you've got a continuous working system. So I was playing a what if game, building a dam, let's say. Well, what could go wrong there? Well, you can have a massive amount of rainfall and it causes the dam's integrity to just break. Let's not build dams over rivers then. Let's build the dam beside the river and influence the river's natural flow to go into the dam, so that if anything happened that went untoward, let's say, the dam's integrity was, the structural integrity was starting to become weakened by whatever you might want to call it, an earthquake happened and it become weak. You then undo what you did because you manipulated the flow of the water and you are now allowed the flow to continue on its normal path, and then you started to slowly but surely empty the dam. You have caused no chaos and you have not flooded anybody, you haven't drowned loads of people, so your dam has been a success because you have come up with an idea. Most people would build a dam over a flowing river. So the river's already flowing, they kind of stop it and give it a temporary sidestep, build the dam and then allow the water to run in. When you get a problem, what can you do? Hope. So, you know, that's why I believe that you being your own critic, you should criticize your own stuff. And I think it helps to concrete your ideas. It helps to make them solid enough for you to walk forward with confidence that you have not left no stone unturned. So I was playing this break it idea with nuclear technology, and that was a mission. So it's not my technology, I haven't invented anything like that. So but it was the what if part that I come to, that if I was to invent something such as nuclear devices, technology and stuff like that, now play the what if game. What if it breaks? What if it leaks? What if there's an earthquake? What if there's a flood? Okay, it's like, oh. In the end, I started finding myself just lost in the what if game, to be fair. And there were so many things that you have to safeguard in order to stop a catastrophe from happening. And it's very hard to do because if it gets in the air, the what if game, how do you clear? Okay, so what if it gets in the water? What if it makes its way into the ocean? What if it gets into the sea life and then you eat the fish? What if it gets into the ground and you grow food there? What if it does? You know, there's a lot of what ifs to it, and to try and counteract every single one of them, I don't know, I predict that I'd spend the next year trying to iron out most of these problems that would be, what if terrorists came? What if this happened? What if we had a critical meltdown? We could hose it down, we could do this, we could do... Sure, but the still contamination level is going to be still there. So anyway, moving off subject right now. So, but being the what if game with that, this is what led me to this idea. Now, I will flip the camera around and show you as best as I can, try and walk you through this, but basically what it does is it uses an MRI machine. It doesn't use the MRI machine to look inside anything, nothing like that. I just want the magnetic pull from it. Now, you can use anything, like if you see a car yard and you've got the electromagnetic device that hovers over, grabs the car magnetically and then drops it elsewhere. One of those would be equally as good. So number two of my device was to use Clockwork. So first we've got the MRI, then we've got Clockwork, and then we have motors. Then we have battery, then we have inverter, and an MPPT charge controller. Now, all of those things when you talk about it, it sounds quite expensive. It is very expensive to probably construct this, but if you're a power company, I believe that you've already got the money to do it anyway, especially in the times of going green. It's a great time to start. So how does this device work? So again, remember, space travel is my number one as I started the video. MRI I think about as electromagnetic field, and electromagnetic field is basically what we have around our planet, and with this it's deflecting solar radiation from the sun and high charged particles that cause us to have the northern and southern lights. So with this in mind, I was thinking, would we get some added protection from any solar flares that were destined towards any space crew, travelers, if you like, holiday makers, honeymoon, and would it offer some level of protection? Possibly. So that's where I was thinking with the MRI and the electromagnetic field. So if you could build a power device that generated power using electromagnetic energy, would you not therefore be adding a layer to the onion of protection against CMEs or solar flares? Now I think the answer is yes. Next one is clockwork. If none of you understand what clockwork is, you can remove a spring, certain springs and cogs and pulleys, especially from the old ones that you can wind up. You have to crank it, and then you let go, and then obviously over time it releases its energy really slowly. Or you can get the really bigger version and crank it and let go, and rather than it spin in a minute hand, you see, this is the fascination with clockwork. Most people think it'll only go as fast as this. That's not true. Actually, if you take out a certain amount of springs, not the ones that contain quartz, and you take out the springs, the old grandfather clocks where you had to pull down on a lever to wind it up. The same process of you taking a kid's toy car, that when you pull it backwards and let go, it flies forwards. That's the type of clockwork I'm talking about. One that you can easily wind up, and when you let go, boom, off it goes. And the same way that when you wind up this clockwork and you let go, it spins really fast. Now, how fast do you want it to spin? Well, that depends on the spring you need to tighten. So what sort of force do we need to pull that spring or tighten that spring? Because there's no way you're going to have about 60 humans paid in a job somewhere to just sit there cranking clockworks. When their shift's over, someone else will take over just to keep power going. That's just ludicrous. So why not make a chain to a clockwork device that an MRI sits underneath, or an electromagnetic field generating device, whatever, it doesn't matter which one it is, that pulls on a chain, and once it lets go and it turns off, the chain just goes back up again. And then it'll have to pull down, and then it will rise back up again. Once you have this type of a device, you are then able to then move on to the next stage of letting all of this energy, like I said, it spins really fast, like a dynamo on a bike. So if you have those old lights, do you remember them? That you'd put this motor against the side of the tyre and it would spin when the wheels spun, it would spin. And what it would do is it would generate you to have a front and back light, and then you stop and then you have no lights. Unless you had a small battery inside there that was able to keep the battery nice and fresh, and you would always have lights even when you stopped. The dynamo version. Now the same thing is going to be happening on this. But rather than using our little tiny dynamo and a small piece of clockwork, we're going to be using large Big Ben sized clockworks, and we're going to be using a motor that is like a wind turbine, or several wind turbines. I think you see where this is already going, don't you? And when we take the MRI or the electromagnetic device, it pulls the clockwork, it lets go, and this spinning then spins all these wind turbines. And you might be like, well, what happens when it stops? You know, it's no good having power that comes and then goes, and then comes and then goes, and then comes and then goes. No, that's why you make 4 or 5 one side, 5 the other side. When these ones are letting their energy go, these ones are getting charged by the MRI machine, and these ones are then finished, then these ones start spinning, and then this one gets charged again, this one gets charged. And this back and forth, back and forth, back and forth into the same series of dynamos, turbines, wind turbine motors if you like, and there will be constantly spinning. With this constant spinning, what are you generating? Power! So you might be like, but doesn't the MRI machine take a lot of energy? Yeah, maybe. So don't use an MRI machine. We can use something that's far more cheaper to generate an electromagnetic field. It's very easily done. Now, when I told you that going into space, these things would work a lot better, the less gravity you have, this invention will work more harmoniously out in space than it would here on Earth. So yes, it would work on Earth, but don't think that that's your benchmark power, because gravity has a fundamentally weird effect on these devices, this new device, that if you were to take it on the moon and it's slightly smaller, less gravity, this device would give you more power. If you were in space, let's say, International Space Station traveling to Mars, this thing would give you so much power because it doesn't have the same gravitational pulls and influences, and wind resistance is another factor. And you'll be like, well, it's a motor. Yet there is still wind resistance is still a factor inside a motor, and so is gravity. It plays a massive role on it, that it would influence the spin. Less gravity, less dynamics of wind exerted on this device, it will cause it to spin much more faster, so the faster it would spin in space. It would also cause more power on the moon. So you'd say that the MRI machine or the electromagnetic device might cause it to generate, it takes a lot of power to operate one of these machines. Kinda. But I think that there would be enough power generated from these devices connected to a series of wind turbines that it would have enough power to operate itself in a closed cycle, and it would also have enough leftover power to operate all of humans' technologies that we have. That is it. There is no downside to it. And if the technology got better on building much more energy efficient versions of MRI machines or electromagnetic devices to pull the clockwork in the first place, it's just like a mobile phone. I always bring this one up. I always say it, don't I? It's just like a mobile phone. Well, a mobile phone had to start like a gramophone. You know, a massive grey old brick thing, you know. Don't take it on a plane, it's too heavy. So, you know, they had to start off really big, like the size of a submarine. People were walking around with submarines to the side of their head. Hello, yes. Before that, they were using a tin and a piece of string. I'm kidding, but still, they were. And, you know, hello, is anybody there? So, yeah, you know, sometimes they picked up, sometimes they didn't, you know. So it had to start somewhere. And slowly but surely, they've got better and better and better, and the quality has got more and more greater, and it's now a camera, calculator, calendar. You can now do this thing called the internet. Battery life is lasting a lot longer. It's a camcorder. You can keep going. It's a television. You can play games on it. It's a games console. What else can you do? Editing, music making software. So you've basically got a computer the size of your hand, basically. If not, it's better than a computer, really, isn't it, technically? Better than a filing cabinet. So anyway, and that's what you've got in your hand. So the technology had to start somewhere, and in the beginning the batteries weren't too great, they weren't too clever, they were quite thick and big and bulky. As things went on, and humanity's needs and demand on these devices, mobile phones and different things, you then start to see that the technology improved. So I guess it's demand and supply. So if power companies started demanding that they needed the parts for these, I'm pretty sure that with their money that they're generating from bills, okay, yes, it has to pay workers, I understand that, nothing is free, there is no such thing as free power. Oh man, that one drives me insane. Free power? Nope, it's not. You've got to understand that all of the hard work that goes into it, from everybody as a collective organization, power companies, different things like that, they have collectively got to put in this energy and pay people to do it. No one works for free. So, this is not free power, but what it does do is it generates revenue from when people pay their electricity bill. I pay my electricity bill, and this money would then be able to be used to better the technology that they've already got and run away with it to the point that they're like, yeah, we've really achieved some greatness with this, blah blah blah, XYZ, they have done fantastic, rah rah rah, and it will run away like a mobile phone. So I am going to flip the camera around to try and get you to see this in a drawing sense, because I try to draw this as best as I can. Remember, there is a version 2 coming to this, because it's been 18 months, give or take, maybe 2 years, and I've been chewing on this idea, and yeah, I thought that when I wrote it out, drawn it, and did all of that weird and wonderful stuff, that it'd go away and it'd leave my head. But it hasn't. It keeps coming back to me. And as it does do this with a few other things, it's like juggling. I throw it away. Or a boomerang. Throw it away for a bit, and sometimes they boomerang back. And usually I take this and I miss something, and as I think about it, juggling them around, I sit there and think, there's a little bit more I could add to this, actually. We could do this, and this. Anyway, so I'm going to flip it around and just help you understand the first part of the principle of this. So number one, electromagnetic field offers you protection in space. Number two, it's clockwork. It takes all of humankind's best inventions that they've ever made, from watches, MRI machines, all the way to the dynamo motor, cogs, chains, pulleys, and all sorts of weird and wonderful stuff like that. And it just basically puts these into a device that gives us power. Batteries as well, again, another fantastic device. Inverters, brilliant, absolutely brilliant. I love inverters, I think they're great. MPPT charge controllers, again, absolutely fantastic. So, you know, let's get behind it. Let's have a look. So I'm going to stop chitter-chattering right now, because 25 minutes, 43 seconds, down to the margin. I've been waffling, but it's to try and help you understand this next bit. So we're now going on to the drawing. Quite simple, actually, but there we go. See you in a bit. Bye. So here we go. It's on a computer. So here's a drawing. Let's have a look, along with some other stuff I got in here. There we go. Brilliant. Lovely. I might need to do a bit of adjusting. I should have done this before I started the video, but hey, I am here right now, and unless I make a terrible mistake, I won't be restarting it. There we go. And by the way, that squeaking is my bench. It's very squeaky. Anyway, so that's what they all say. Yeah, I'm sure. Anyway, so here we have it. So we've got our very depicted drawings of an MRI machine here. We have a battery and inverter over here. Now, here's how it works. So obviously you can see the one says on, one says off quite clearly. And the one that's on is pulling the chains down. These are the clockwork. So that's the clockwork I was telling you about. But the difference with this clockwork is it's specially built clockwork that has... So whereas a clock takes 24 hours, you know, spin really slowly. These ones spin fast, rapidly fast. Once you let go of this chain, that's it. It zips all the way back up, and these spin insanely fast. So here we have another one. Here, there's very thin right here. Let me see if I can zoom into that. Yeah, there you go. There's a very outline of a cog there. That's very important in a minute, because this one moves from here to here, and it makes a nice smiley face, but there's a reason why it does that. So yeah, the power starts off in the MRI machines, and it goes into these clockworks. Okay, now these clockworks are from one to another. There's loads of springs and different wires and metal bits and cogs and all sorts behind all of this. So just to give you the easiest version, this is how it would look. These are all connected to one main pulley system, which is then connected to the top pulley system at the top here, so that when they start spinning fast, it will then spin this really fast, which then spins into here. It then knocks into this wheel, and then from this wheel, it then goes into a series of motors, and these are the dynamos that spin insanely fast off of these clockworks when they're released from the MRI machine, which pulls down on the chains to charge them up. Now while this one's letting go, because it's off, these chains are now going up, and this clockwork is now spinning really fast. In the meantime, however, this side of the clockwork is now on, and it's now pulling the chains down. So MRI machines, remember, they will pull anything metal towards them at an alarming rate of speed, and they will... there are some videos on YouTube that you can look up where you can see MRI machines that will basically take massive oxygen tanks, and as soon as the MRI machine's turned on in the room, pa-ding, they stick into the middle of the tank. Some people and doctors have been impaled onto these and have been wedged between an oxygen tank or wearing anything metal. Anything metal, staplers, you name it, whatever they've got in the room, everything has to be metal free. If it's not, it will be pinned to the inside of this device. That's how strong it is. It is so strong that when these are turned on, you have to then have a specially trained technician to come and turn these off, to then remove the person off of here if they have any metal, and that's why they say no metal. So good luck trying to get yourself off of one of those once you've been impaled to it. It's almost impossible until the machine is turned off. So again, maybe the difficulty is turning these on and off. So I had another idea, which is on another one. I should grab it in a bit. Maybe I won't. That basically these would then lower into the floor, and once they've lowered into the floor and they keep going lower, 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 the influence of the MRI machine will become less, 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 and then these would then start to have a loss of magnetism on the metal rods here, and then they would start winding back into the clockwork. And then when you needed to turn them on, they raised up. So one went down, one came up. Charged this one came down once that one had charged, and then this one goes down, and then up, and then down, and then up, and then down, and then basically these would go zoink, 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 up and down, up and down, up and down, and then this would cause this bit here to continuously spin fast. And then once this one has then slowed down slightly, it then moves over to this side. This one then starts spinning into that one, and it slows down, and then it moves from this side to this side, this side to this side, taking the energy built from these, and it spins it off into there. Once it's done, it then moves over to this one really fast, and then it starts taking its energy, and as I say, it takes the energy and then runs it into the motors over here, or dynamos. There's a series of them, and they will generate. So if you imagine each one of these dots is a wind turbine, each one of these, think of how many villages that is. Really, that's incredible. So if you were to think about it, 8 villages, they usually say one wind turbine can power 8 villages. Not for this one, there's 8. So that's 8 villages that send its power into the grid, and it takes some of its power on a charge controller, either using an MPPT off of the power. I mean, imagine the power off of here. I mean, you know how much power you can get off of your alternator in your car? Why stop there? Add a series above it of alternators above it. You know, up here, put some alternators as well, or add some more of these turbines. As long as these turbines didn't exceed the forces, and they were able to spin really fast to the speed of a comfortable spinning turbine, keep adding these until you reach that limit of I can no longer add any more without slowing the system down. So you might be able to get 8 and another 8 and another 8 and another 8 and another 8 just off of this many. And this power just constantly cycles from here to here onto the grid, that leftover bit, and some comes back in to feed the operating system itself, and over and over and over, and basically you're left with the leftover lolly. So if it takes just one of these turbines, I really don't think it will, but let's just say one of these turbines, wind turbines, was enough to power the system itself. You have then got another 7 that are able to feed that energy onto the grid. That's where I'm thinking with this. I mean, I hope it's able to, free power 24/7. It's not free as in it's giving it to you for nothing. Think of how many people would have to build these. Think of how many people would have to build these. Think of how many people would have to build these, or these, or these, you know? And then getting it to your home. There's a lot of man hours, woman hours involved in lifting this off the ground. So it's free power because I made another one that was 2 power and 1 power. So maybe I spelt my free a little bit wrong. Terrible. I know, very bad. But it's not free power. And the other idea of it being power 24/7, it's basically freeing the power from the system. You have to free it from this because you are going to have to take into consideration that this uses some power. So how would this work and tie into space flight? Well, quite easily. This would generate your magnetic field. Lovely. These would then work on your space station. Remember I said that in space these spin faster. A lot faster. It doesn't have wind resistance to contend with. In a gravity-less environment, how fast do you think that will spin? I think very fast. So again, it's going to be generating more power in space, or more power on the moon, more power on Mars, because it has less gravity being a factor on all of this system. Now, obviously I've stretched this out to make it really big, but this would fit into a room. This would fit into a room quite easily, as long as these were connected to the ceiling quite strongly, and I must admit these need to be reinforced to the roof, because if they weren't, the MRI machine or any device that you use to pull down these cogs would pull the whole system down. And that's not what we want. So, and these pulleys would have to be done perhaps not in metal or anything magnetic, because we wouldn't want them to be magnetically attracted to this. So we would probably move all of these and the MRI devices out the way, and the pulley system would run this way. Same pulley system, but the cables will just be a bit more longer, probably be a bit more like this top one here. So, you know, it would be like here, the device would run here, and these would be over here, which would be these. But anyway, so it just, we wouldn't have any influences on here from this or this. So I tried to get it as central as possible so that it wouldn't interfere, but I'm not sure the magnetic field would really care where you put it, to be honest. If this was metal, it's going to hold on to this just like it's going to pull onto this. So these being well out of the way so that it was at that right distance, that these were not influencing this. And this will generate you power quite a lot of the time. And if you switched from one to the other, maybe two's not enough, so have three. And if you've got three, 1, 2, 3, when this one's banging its power into there, and this one's charging up, and this one's charging up, and then this one starts whizzing into there as well, and it moves over to this one, and then it moves over to the third one over here, and then it goes back to this one, which is now fully charged, and then it's all pulling. Wow, I'd love to listen to this. This would sound quite nicely, to be honest. All those whizzing motors and everything else. Oh yeah, so here we have the Clockwork, MRI, and your motors and your dynamo, charge controller, and a set of batteries and an inverter. Maybe we could run these off of an inverter, saving even more power off the grid and sending even more to the grid for people's homes, houses, and different things like that. And would there be waste? Yes, there would need to be maintenance done on these. These would eventually burn out, and they'd need to be recycled, redone, changed. And once they're changed, replaced. And again here with these ones, yes, there's going to be wear and tear. There always is going to be. But on your most sunniest and windiest days, this would not be a problem. Having a day of maintenance on here, the power from the solar panels would be able to take care of humanity's needs for, I don't know, 8 hours, so that you can replace some of these, or replace any of these if they worn out or got worn anywhere. I don't think it would take that long, but hey, depends on your teams. So yeah, that's how this works in cycling and giving you enough left over to power humanity. And not only that, it might let you have a honeymoon. You know, if you always wanted a honeymoon. Anyway, maybe not. Maybe you've always wanted to go ice skating on Europa. You see, this is the possibilities. Or perhaps you wanted to surf the rings of Saturn. You know, I have no idea. Perhaps that's your thing. You know, I don't know, whatever your thing may be, but mine obsession is space travel, and I believe that we can, once we've got some decent amount of power to get there, we've got enough power to make oxygen, we've got power to make different weird and wonderful stuff, but we've also got enough power to get to places, bring back some nice lovely more rocks to go and build some more mobile phones and different technology, and it can still get really good without depleting Earth's minerals and resources. That's what I like about this. Actually love it. Just like that exhaust pipe on that car. It doesn't sound bad. It sounds really bad. Anyway, so yeah, as of that, I am going to leave this video right here, and there is a version 2 to this coming up. So a little bit more tweaked the system a bit more, so that's going to be quite fun to share with you all. So anyway, again, My Contentions Monday. Share with me any ideas or any contentions that you have this week. What are you considering doing? Is there anything great or fun that you are up to? And we will cheer you along for sure. So if you've got any ideas of your own, share them out to us, and we will cheer you along for sure. We'll support you. So yeah, hashtag that one in the bottom, My Contentions Monday, and explain what you're doing or what you're up to or what you plan to do for the rest of this week. So we want to know, we'd love to hear. Don't forget to give this a thumbs up if you like it. If you don't, well, good. Thanks for still stopping by anyway, and good to know you. And anyone that is there, don't forget to subscribe and tickle that little bell, you know, give it a tickle. Give that a jingle bell, you know? So yeah, catch you in the next video. And I will see you hopefully on Friday, if not Monday. Who knows? See ya. Bye bye.